Hi. So today we will be talking about the scaling wall and understanding AI's compute, possible deadlock or wall or crisis. So for the last 5 years, artificial intelligence has followed a simple rule. More data, more compute, more parameters equals better AI. It was predictable. It was reliable. It was the foundation of a multi-trillion-dollar bet by every major tech company on earth. And it's beginning to look like it's just stopped working. So what we're going to try to do today is to understand exactly what hitting the scaling wall means, why it matters, and what happens next. So it isn't just hype or speculation. It's based on leaked internal documents, published research, investor reports, and the direct admissions of the people building these systems. So hopefully by the end, we would be able to talk a bit more about what scaling laws are and why they worked, what hitting the wall actually means, and then the Orion GPT-5 story nobody is really maybe talking about as much, and where the industry goes from here, why this changes everything. So we'll begin with the basics. So in 2019, Canadian computer scientist Richard Sutton published an AI essay called The Beta Lesson. So his argument was simple but profound. Now, throughout AI's 70-year history, approaches that leveraged raw computational power consistently outperformed clever attempts to encode human knowledge. Now, the implication is that we didn't need to understand intelligence to recreate it. We just needed bigger computers. So about a year later in 2020, OpenAI researchers published a paper that changed the industry. It was called Scaling Laws for Neural Language Models. So they demonstrated something remarkable, that AI model performance improved in predictable ways. As you scale 3 factors, that include model size, which is number of parameters, data set size, which is amount of training data, and compute, processing power used for training. The magic, when you scaled all 3 together, performance followed a smooth power law curve, which, it wasn't just better, but it was predictably better. But here is what that means in practice. OpenAI's 2020 paper showed that test loss, a measure of model inaccuracy, decreased as compute data and parameters increased, and that relationship looks like it looks like this. If I can say the numbers so it's understandable. Loss is directly proportional to compute, or C raised to power minus 0.05 times n raised to power minus 0.076 times D raised to power minus 0.095. So it's like the loss function is directly proportional to compute, which is measured in flops, raised to power minus 0.05, numbers of parameters, raised to power minus 0.076, and then data set size, raised to power minus 0.095. So those tiny negative exponents are crucial. They mean you get diminishing returns, but predictable ones. So you might ask, what did this enable? So it enabled the discovery, this discovery really had massive implications. So it enabled, for researchers, it meant that they could predict how well a model would perform before spending millions training it. And for investors, they had a formula showing that money spent on compute would translate to better AI. And for companies, they could plan roadmaps years ahead with confidence. And this is why we got GPT-3, which was 175 billion parameters in 2020, and GPT-4, which was around approximately 1.8 trillion parameters in 2023. Massive data center investments. NVIDIA becoming the world's most valuable company. That's the reason. So everyone believed the curve would continue. Just keep scaling, and AI would keep improving towards AGI. But you see, here's what most people missed. Those scaling law graphs, both axes were logarithmic. That means what looks like steady improvement is actually showing extreme diminishing returns. Oxford philosopher Toby Ord analyzed this in his 2025 essay, The Scaling Paradox, where he pointed out to get linear improvements in AI accuracy, you need exponential increases in compute. So in computer science, exponential source usage for linear gains is typically considered a sign that a problem is intractable, that your approach fundamentally doesn't scale. So the scaling laws worked, but they worked badly. We just didn't care because we had exponentially growing resources to throw at the problem until we didn't. So in 2024, OpenAI began training a model codenamed Orion. This was supposed to be GPT-5, the next giant leap that would prove scaling still worked. Now, according to the information, Wall Street Journal and Fortune, all citing an anonymous OpenAI employee or employees, here's what happened. At 20% of training, Orion matched GPT-4's performance, exactly what scaling laws predicted. Now, at 100% of training, the improvements were far smaller than the leap from GPT-3 to GPT-4. So in coding specifically, Orion showed no consistent improvement despite consuming significantly more resources. So OpenAI ran at least 2 major training runs, each lasting months, and both fell short of expectations. So the model that was supposed to be GPT-5 got downgraded to GPT 4.5, and it launched from February 27th, 2025, 2 years after GPT-4. And even then, OpenAI's blog post originally called it not a frontier model before deleting that line. So users on social media at the time called it a nothing burger. A critic, Gary Marcus, said improvements didn't even justify the cost. And even CEO Sam Altman warned it won't crush benchmarks. Now, the information reported similar struggles across the industry. If you cross over to their counterpart in Google's Gemini, latest version falling short of internal expectations also at the time. Anthropic's Claude next generation model was delayed at the time. Meta also grappling with diminishing returns on new models. So this isn't one company hitting a wall, it's the entire industry discovering that the scaling curve has flattened. So, but you might want to ask, what is the barrier? What changed? So there are 3 barriers here, basically. According to research from Epoch AI, Foundation Capital, and Heck Paris, they identified 3 interconnected barriers, and I'll talk about them. So the entire corpus of high-quality human-generated public text on the internet contains about 300 trillion tokens, enough to fill 600 million encyclopedias. Now, Epoch AI estimates AI models will have consumed this entire library sometime between 2026 and 2032. So we're running out of internet to trade on. Former OpenAI chief and scientist now, Ilya Sutskever, said at NeurIPS 2024, by the way, NeurIPS is a conference, a computer science conference, which means neural information processing. So in 2024, he said that pre-training as we know it will unquestionably end. The data is not growing because we have but one internet, unquote. And he said this, yes, at the Neural Information Processing Systems Conference, which I said is a computer science conference. Now, secondly, compute bottlenecks. Now, there's a hidden constraint called the critical batch size. Beyond this point, throwing more GPUs at training yields drastically diminished returns. You can't just parallelize training infinitely. At some point, you are waiting for sequential batches to process, and adding more hardware doesn't help. Additionally, there are physical manufacturing constraints. TSMC's CoWoS packaging capacity limits GPU production. HBM, high bandwidth memory chips, were nearly sold out through 2026, and wafer production was growing at 30 to 100% annually, but that's not infinite. So you see the building blocks we're in a state where you would say some sort of a concerning state. So, and thirdly, now this is the core issue. Current models show logarithmic returns to compute. So doubling AI accuracy requires 10 times more compute. Tripling it requires 100 times more compute, and that's just not sustainable. As compute costs spiral and improvements shrink, you hit a point where the economic return doesn't justify the investment. And Foundation Capital, put it bluntly, in quote, to reach the reliability needed for an AI to write a scientific paper, a basic requirement for a system that could advance AI research autonomously, we'd need 100,000 times more high quality data than currently exist. We don't have that data. We can't generate it fast enough. And even if we could, the compute requirements would be astronomical. So let's talk about the numbers. OpenAI's initial projections was $1 trillion in compute spending by 2030. Revised projections in February 2026 were $600 billion. That's a $400 billion cut. Why? Because the returns weren't there. Sam Altman said, while speaking to the Register, which is an online information portal, said, we were wrong about how much compute we'd need. Turns out algorithmic improvements matter more than we thought. So throwing money at GPU doesn't automatically make AI smarter, clearly. Now, tech companies collectively investing over $1 trillion by 2027 based on assumption that scaling would continue delivering exponential improvements is one thing that is still interesting or still tells us that for some people in the tech space, they've not really given up on that idea. Now, Google alone is investing $185 billion in 2026 alone. Meta is investing around 60 plus billion US dollars. And Microsoft, massive Azure AI build-outs. Amazon is competing also to keep pace. So this investment rests on a premise that's no longer holding. As any Scale co-founder, Robert Nishihara, told TechCrunch, if you just put in more compute, you put in more data, you make the model bigger, there are diminishing returns. In order to keep the scaling laws going, we also need new ideas. So where do we go from here? OpenAI is valued at $300 billion, and some reports say $350 billion seeking. Anthropic also seeking similar valuations. These valuations assume AI will become AGI through continued scaling. But the economics are likely to be grim because sky-high valuations of companies like OpenAI and Microsoft are largely based on the notion that LMs will, with continued scaling, become artificial general intelligence. And as cognitive scientist Gary Marcus said in November 2024, that's just fantasy. So if scaling doesn't work, those valuations don't make sense. And trillions in planned infrastructure spending might not generate returns. So what next? Now, the truth is that the industry hasn't given up. They've sort of pivoted. Microsoft CEO Satya Nadella, who was speaking at Microsoft Ignite in November 2024, said that we're seeing the emergence of a new scaling law. So here is what he's referring to. He's referring to test time compute, which is the approach behind OpenAI's O1 reasoning models. And this is how that works, in case also you're hearing it for the first time. Traditional GPT models train once on massive data, then answer instantly. Reasoning models on their own train on smaller data sets, then use more compute at inference time to think before answering. So it's the difference between. So pre-training scaling make the model bigger, which is what happens with traditional GPT models. Test time scaling give the model more time to reason. And some people like Anjani Midha, who works with Andreessen Horowitz, has called it that we are now in the second era of scaling laws, which is test time scaling. Does it work? Which is a big question. Early results are mixed. OpenAI's O1 can solve complex math and coding problems by showing its reasoning. It's genuinely better at specific tasks. But, and this is crucial, philosopher Toby Ord analyzed O1's performance charts and found they also show logarithmic returns to compute. So the graphs look good because both axes are logarithmic, but you are still getting exponentially worse efficiency as you scale. And as Ord writes, increasing the accuracy of the model's output requires exponentially more compute, and that's not generally a recipe for success. So test time compute might work better than pre-training scaling, but it's not a magic bullet that escapes diminishing returns. Now, where do we go from here? Thinking about the future. 4 possible futures, perhaps, from what the reports and the analysts and the papers and documents I have read and synthesized are saying. Now, some people believe AI-generated data can replace human-created content. Use AI to create training data for better AI. But the risk here is that there could be model collapse, where AI is trained on AI output, just replicate their predecessors' capabilities without improving. It's like making a photocopy of a photocopy. So early synthetic data works for math, coding, where verification is easy. But for general knowledge, the jury is out. Another scenario I see here is one I would say is more like a case where we have architectural breakthroughs. So maybe we are using the wrong approach entirely. The human brain achieves general intelligence without reading the entire internet. Yann LeCun, who is Meta's chief AI scientist, has long argued LLMs won't get us to AGI. We need fundamentally different architectures. So if someone discovers a learning architecture with much better returns to scale, we might see a step change in capabilities. But that's a hypothesis, not a plan. So another scenario I might see here, which is the third scenario, is maybe we've hit an S-curve. Earlier exponential growth now entering the plateau phase. So LLMs will remain useful tools for statistical approximation, but won't become AGI. AI doesn't disappear. It just settles into being what it is, good at some things, limited at others. So the hype deflates, valuations adjust, and we use AI for what it's actually good at. So another scenario I see, which is the fourth one and the last, but not the least, is most likely combination of all three. Better architectures, synthetic data, test time compute, plus specialized models for specific domains. So instead of one giant model doing everything, we get ecosystems of specialized AIs working together with human oversight where needed. This is less sexy than AGI, but more practical. So regardless of which future materializes, there's going to be a financial reckoning. If returns don't materialize from the $1+ trillion being invested in AI infrastructure, someone's holding the bag. Could be investors in AI startups, big tech shareholders, maybe data center operators, or even GPU manufacturers, or of course all of the above. So the question isn't whether scaling hit a wall. The question is whether the industry can pivot fast enough to justify the investments already made. So what does hitting the wall actually mean? It means the simple rule, more compute equals better AI, has stopped delivering exponential improvements. We're getting logarithmic returns instead, which means progress is slowing dramatically relative to resources invested. And it doesn't mean AI stops advancing. It just means advancement becomes harder, more expensive, and less predictable. The Orion story is the canary in the coal mine. What was supposed to be GPT-5, a giant leap forward, became GPT 4.5, an incremental improvement that won't crush benchmarks. That's the wall. Not a dead stop, but a dramatic slowing that changes everything about AI economics, timelines, and expectations. So the industry knows it. That's why OpenAI cut spending projections by $400 billion. And that's why everyone's pivoting to test time compute, synthetic data, and searching for new approaches. So conclusively, or in conclusion, the 2010s were the age of scaling. We're now in what Ilya Sutskever calls the age of wonder and discovery once again. Whether that leads to breakthroughs or disappointment, we'll find out together. But one thing is certain, the simple days of just adding more GPUs and expecting magic are over. Thanks for listening. And if you found this valuable, let me know in the comments what you want me to deep dive on next.